So this talk is called Learning from Configuration Management. If you had looked at the program earlier, there was a gentleman by the name of Eric Maxwell. Unfortunately, he was unable to make it, so this is the first time I'm delivering this talk, and these aren't my slides. It's something that's near and dear to my heart, so if I do have to look at the speaker notes a little bit, please bear with me. But let me maximize this window real quick. There we go. So I didn't introduce myself yesterday during the lightning talk, although I did share lots of opinions on configuration management. My name's Seth Thomas. I am currently an evangelist and an engineer, and so I stole this from one of my friends. I'm an evangineer because evangelist has weird connotations in other parts of the world that aren't the US. And so I don't usually like putting that on my business card. I've worked for Chef for about 2.5 years now. Prior to Chef, I was a video game release engineer, so for MMOs. I worked in higher education identity management, so very large universities in the US. I also worked at, I mentioned I worked at Basho, so doing distributed systems evangelism and operations engineering. I really like systems at scale, and I don't know anything but scale. The very first job I had was working on 38 node clusters, and then I had 26 of those. And this was in 2007. This was before we had Mesos or schedulers or anything like this. We wrote this all ourselves in C++ because we were a game studio and we know best, and we don't share very well. So obviously I'm passionate about configuration management. Configuration management changed my life. It's why I work at Chef. There was a long time, like I said, I've been part of the Chef community for several years. I think we're going on year 6 or 7 now. To the point where this year I was awarded the Awesome Community Chef Award at ChefConf because of my work on Test Kitchen and Bento, which is probably where you've seen my handle before, or you've probably opened an issue and I've said something mean. But everyone loves configuration management. It's brought us out of kind of like the dark ages of system administration. I remember writing my shell scripts, and then I remember using bconfig2. Has anyone actually used bconfig2? Wow, okay, that's what I thought. It's a really old config management system. It was basically dropping templates on systems. That's all it could do. So I've been using config management in various flavors for most of my career. Especially as a release engineer, your goal is to automate every piece of that process, and then you realize that you can't actually rebuild your build pipeline unless you've written some configuration management. So these are the configuration management tools that we kind of think of. If I had, so like I said, these aren't my slides, I would have added MGMT to that stack as well. We have our typical configuration management tools. CF Engine is kind of the grandfather of all the configuration management systems, and Mark Burgess's books on promise theory and everything really kickstarted the kind of second generation of config management systems. So this is where you get Puppet came along, and then Chef, and then Ansible, and then SaltStack. And we also have Console up there, and a lot of people will be like, well, Console's not a config management system, except plenty of people, as we've even discussed here, are using it as a config management system. It can drop templates just like the other systems. It can also set MVARs and things, so you can actually trigger config management changes on your system, even if you don't think of it as a traditional configuration management system. So this is actually my favorite because it's the MMORPG learning curve. So for anyone who's played EVE Online, the top bit is the learning curve for EVE Online, and over time spent playing. And this is actually just representing the kind of difficulty curve with configuration management. Configuration management takes you only so far. It's not that it's bad, it's just that we got really excited about these DSLs. We started trying to write clever things. And we took this really big step forward, but there is still this cliff where configuration management can't solve all of your problems. And we had some questions during the Ignite that I was kind of deferring to this talk, and we'll kind of cover how we've changed our thinking at Chef and some of the cool things we've done around kind of changing how we have approached configuration management. So we automated all the things, and it was good, and we were very, very happy. But then we started having to write integration tests for our configuration management and unit tests for our configuration management. And then we started trying to do things like complicated topology changes with configuration management. And then we cried, and then we drank heavily. This is kind of where we're at in the kind of world of configuration management. We see new tools, second generation stuff with regard to containers. So we have Docker, Mesos, we have schedulers like Kubernetes. There are all these great new tools, but we still haven't grappled with a very core piece of complexity. So here are some of the things that could be better in our config management world. Centralization. Centralization is something that you either don't want or you do want. There's very rarely an in-between. So we always end up having these centralized sources of truth. In the Chef world, the Chef server. Puppet Master D. This is a centralized source of truth. Now you can have those things go down and the nodes can maybe still converge, but you still need HA and disaster recovery for these things. What happens if your Chef server is unavailable? So then you say, okay, let's go entirely masterless. Let's go Ansible for everything, and everything lives, all the configuration data lives on my local laptop, because that's a really good idea too. So we either create too much centralization and rely on it, or we have no centralization and then it bites us. Immutable infrastructure. Immutable infrastructure is awesome, except most of us don't actually do immutable infrastructure, because if things were fully immutable, nothing would actually ever change. The problem is we are changing things inside of these containers, and we are changing things even when we build, a static Packer image. So we build this AMI out with Packer. There's still something on that box that is going to change. You're always going to get configuration drift, and that's why we say, oh, configuration management is great, but you still get little things around drift. You get things around systems level access. This is really a problem. Is there's the kind of dream of immutable infrastructure, and then the reality of trying to run immutable infrastructure. It can be done, but it is challenging. Hidden dependencies. Who's ever installed an operating system package that didn't actually do what the package is supposed to do? Does anyone want to raise their hands for system packages that are broken out of the box? Hidden dependencies. You always find some new thing on your new distro, or it's a new version of Ubuntu, or something like that, where there are these hidden dependencies that you didn't plan for, and then you end up having to install some devel library on your production servers, and then we return to the drinking problem. So, you don't know. There's a high amount of trust in distros. I hate all operating systems equally. They've all burned me in some way, shape, or form. I actually have a Microsoft Certified Professional certification for Windows 2000 Advanced Server. I hate it just as much as every single other operating system, because they all have these hidden dependencies, broken packages in the distributions. That's usually my big one, is the broken packages. Or fun things like Apache being named differently on every single distro. So yay, config management, it makes all of this easy, right? Orchestration, that can also be better. Trying to do coordination and orchestration with the existing config management tools is somewhere between difficult and painful. They're not necessarily built for this task. A lot of the times people are trying to use config management systems as service discovery, or use them as lock systems, and it's kind of, yeah, it can do that, but should you really be doing that? And is it really a good idea? Case in point with Chef, you're like, oh, I'm just going to use a data bag as a simple lock. Then you forget that Chef server has to index things, so you have a 60-second lag, and what happens if you return an empty result? Did you actually account for that in your recipe code? This happens all the time. Orchestration ends up being very brittle in the ways that we have tried to design it. So here's what we want. We want choreography. So this is the Radio City Rockettes, and they obviously are dancers. They don't actually, there's not somebody out there sitting in front of 150 Rockettes and actually coordinating them. There isn't a conductor. The reason that the Rockettes are able to dance and swing and kick their legs all in unison is because they're paying attention to their nearest neighbor. That's how this whole thing works. And that's kind of how you may have heard the term choreography before in systems operations, but we're kind of thinking orchestration is not really the thing you want. You want self-organizing systems. Orchestration has a single point of failure. So this is the Rocket example is, so you have, Rocket A next to Rocket B. If one person's tired and they're swinging their leg a little bit slower, the Rocket next to them is actually compensating for that, and then the person next to them is compensating based on that. So this is kind of how we're trying to define choreography. So this is where it starts to get much more interesting. Application release patterns. Who's tried to use config management to actually deploy an application? Was it fun? Oh, okay, so get mixed answers. So application release patterns are very difficult and orthogonal to configuration management. Configuration management is really good at configuring the system, and it's generally really bad at trying to make it do anything else. You can make it do it, Plenty of things. You've seen there's a Git, there's a deploy resource in Chef. Please don't use it. But it's yet another thing to manage. And then you're trying to actually configure your system and your application using the same framework, and they have sometimes overlapping needs and sometimes completely separate needs. So, tool chains. Again, operations at web scale is the ability to consistently create and deploy reliable software to an unreliable platform that scales horizontally. Excuse me. We lack some of the tooling around actually making these application release patterns good because the tool chains themselves are brittle. So console here can actually play a dual role. So it can be service discovery and configuration management. But then you're saying, okay, well, I've got service discovery over here, but then I need to have Chef or my config talk to service discovery. And you've created what I would consider unneeded complexity. It does solve the problem in a better way than doing it in just the configuration management framework. But again, you're setting up brittle systems that are not necessarily aware of each other inherently. Each of these tools in this tool chain come with their own learning curves and idiosyncrasies. You don't want to add complexity to complexity. So, what would it look like if we built for choreography instead of orchestration? So this is pretty simple app that we're going to build. So we want to replace command and control with fleet coordination. So what would this look like? So this is our basic 3-tier app. We actually want to have the database decide to reconfigure itself. And when the database decides to reconfigure itself, it's actually going to, the other apps in the stack are going to notice that the database is in maintenance mode and reconfiguring itself. And so they're going to reconfigure themselves to maybe push a redirect instead of just serving up a 500. So you get a nicer way to actually divert this at the presentation layer. So this presentation layer can then trigger logic to display a friendly unavailability message. And then once the DB is done configuring itself, the app would notice it's back and ready to accept connections, and then the app layer could actually notify our Nginx front end and actually say, hey, I'm ready to serve pages again. This sounds real simple and really ideal, but we don't actually have tools that do this super easy, super reliably, and actually have an awareness of each other. I think there's another animation in there. Come on. There we go. So what if we built for large distributed systems that are topology aware? A lot of talk about Distributed Systems Day, which I'm super excited about. What if we had a way to run these immutable systems with flexibility and ease? What if we had a way to strip out hidden dependencies and then on top of that simplify the tool chain? This is where Habitat comes in. You notice it's Habitat by Chef, not Chef Habitat. Habitat is its own thing. I point that out because everyone says, oh, how does it work with Chef? Habitat is its own approach. But config management isn't dead. This isn't the death of configuration management, and we don't at all see Habitat replacing configuration management anytime soon. Configuration management is something that you're going to need. It's really, really good at configuring your base OS. It's really good at setting up services, maintaining things, and also having convergent behavior. Things like storage, networking, all these things are going to be sorted out before you even think about your app. So configuration management, still alive and well, don't fear. So we're going to look at Habitat real quick and show you why you might want to use it and some of the cool properties that it has. So, Habitat components. The first one is a Habitat Studio. This is so it says application packager, and please don't think package manager for your operating system, because that's a scary thing. This is what allows you to actually create what we call a Habitat package. It's a clean, self-contained, minimal environment where you can develop, build, and package software. This runs locally in the form of a Docker container, so you don't have to pollute your system with anything. So you just build your target application in the studio, and then you have your Habitat application. It also helps you prevent unwanted dependencies from your system from creeping in. You notice this if you ever tried to build something that has OpenSSL on OS 10, and you just don't have you end up linking against the wrong library because you didn't know, or because you didn't run an update, or because you didn't update brew, or some god-awful thing like that. There's also Habitat Plan. This is the instructions to compile and install the things. Now, I said yesterday that Docker made bash cool again. and really, really excited that they made bash cool again because our plan is a plan.sh. So this is the core of every Habitat app. This actually is something that you'll put in all your dependencies, the application that you want to configure, any of the compile options, as well as being able to interpolate TOML variables inside of this. For those not familiar with TOML, it's just yet another format. It's similar to INI format. So the nice thing about this is you get consistency, ease of use, and portability and automation that travels with the application. We'll talk more about that in just a second. And then a Habitat Depot. This is pretty much how it sounds. You can think Docker Hub. It's got the same kind of namespace format as GitHub and Docker Hub and all those other things. This is where you'll upload and download things. And then finally, the real magic and my favorite part of Habitat is the Habitat Supervisor. The supervisor is an intelligent runtime that actually does deployment and service discovery, deployment coordination and service discovery. So this is great. So this is Joshua Timmer, one of our longtime chefs. Habitat packages end with a .heart extension because we thought that was super cute. So this is how you go from 0 to Habitat. There are a lot of steps under 2. Only 2 of them are actually required. So you're going to start. You're going to package your app. You're going to start with your plan. It's as simple as creating a Docker file. There's no more complex than that. Then you're going to start by launching your build environment, which is the studio. So Hab Studio, enter. And you'll actually log into the studio. Then you'll define your plan. Somebody put Vim in here, which is super cool by me, but also is like a real easy way to start a fight. So I don't know why they did that. I think we built Vim and Emacs into the container, but don't hold me to that. And then you can define your configuration template, define the configuration defaults, define hooks, create signing keys, so symmetric keys, and then build your artifact. You don't actually need to do all the steps in there. Some of them are optional. So the things that required, step G and the plan, A and B, and a key, F. So you don't actually need to define the hooks. That is entirely optional. And we'll talk about the hooks in just a second. So I've totally led you up to something, but there are probably going to be a few questions. On this last command, you see run and test your artifact, this Docker run. It doesn't have to be Docker. It's just that people love Docker, and it's an easy way to run things locally in an isolated environment. So that's the default packaging format, but we also have several other packaging formats, which we'll cover in a second. So this is the technology. So as part of an artifact, so the supervisor is built into the artifact. So you can think of I like to think of this as you have your app, and then you've basically given any app that doesn't have an API, and service discovery, and awareness of other nodes in a cluster. So you use predefined plan to manage application behavior. So failure modes. Habitat actually has 3 built in, or it's 3 built in at the time these slides were written. Habitat is entirely open source, so we have people committing to this every day. So the 3 that are in there right now are standalone, initializer, and leader. Standalone is how it sounds. There's only one app in the cluster. Initializer, this is the instance that needs to be up first. Think Cassandra. Like that's exactly what this is kind of there to target, as well as leader follower. They all exist in a ring, so all these apps. So if anyone's used Erlang and has ever thought of, used the Erlang VM's ability to auto-connect to other Erlang VMs and create a ring, very, very similar model. Nice thing is the rings have no single point of failure. They self-organize with other supervisors to make sure that there's always a leader, or the initializer is actually up first so that the followers can then spin up their database or what have you. The supervisor executes a variety of hooks. So you have init, run, health check, reconfigure, file update. So you have a bunch of predefined behaviors. And then this is probably the nicest part. The supervisor is accessible via REST API. I can just hit it and say, hey, /election, /gossip, and see stats on the last elected leaders, the actual config that I've put into the supervisors, and also the health. That's one of the big bonuses. You've got built-in health checking now. Built-in health checking that you get to write that is custom to your app. So, security, we did think of this. So in the same way that you actually have this secret payload and your pub key, all the nodes in the ring have to have a key. You have to have a key to talk to each other. We also have origin verification. So when you grab a Habitat package off of the depot, you can actually verify that independently with keys. There are a lot of management benefits with Habitat and application automation. For example, you can carry out automatic safe atomic software updates because you just drop in a new Habitat package over the old one and it goes away. So for those really into encryption, we actually wrote our own Rust library based on NaCl. Habitat packages are also signed using Blake2B checksums, and Blake2B is essentially SHA-3 grade hashing, but much, much faster. So we're making sure that we're meeting all the things. And if you want more information on all the encryption algorithms in there, it's one in the repo, or you can come ask me later if you're an encryption nerd. So the nice thing is that these supervisors can be configured to watch a depot for a new version of the package, so they can actually automatically update themselves. They see a new version. We have multiple update strategies that you can write. Right now, there's only one update strategy, and it's at once. But it's also one of those things that we have made pluggable, so you can actually write things in there. And the nice thing is, like I said, it's topology aware. So as topology changes, you don't actually need to touch your application. So there's not that, oh no, my monitoring system said something's failed. My monitoring system alerts something. That thing then initiates a change. Then console flips a bit, and then my config management hears from that. That's a long feedback loop. Habitat is actually gossiping these rumors of leader election around the ring and can just make these changes as they happen. So you don't actually have to worry about what your app is doing if you've actually written the failover into the topology. It's not difficult. And this is basically how Habitat comes together. Now, I mentioned that we will export a Docker container by default. Like I said, people love Docker. The cool thing about Habitat is it doesn't have to be run in Docker. It doesn't have to be run on bare metal. It can be run anywhere. It can be run anywhere that runs Linux kernel 2632 or above. This is an artifact that you just drop in somewhere. There's no installing system dependencies, so there's no installing Python devel to get your Python app to compile on your OS. Because they're your OS concerns and they're your application concerns, and that little bit where they overlap is usually where all the bad things happen. Think OpenSSL. Because you didn't update your distro packages. And then you do update your distro packages, and then everything breaks. Habitat makes sure that this is all self-contained inside the Habitat app. So my operating system is over here. If I want to swap out my operating system, I just grab a new AMI, slap my Habitat package right in there. So like I said, I just want to make that clear. So AMI is bare metal. We're not limited to anything. Like I said, Linux kernel 2.6 or above. And the really cool thing is Windows support. We've actually landed several pieces that we've needed for Windows support. So in theory, you can actually drop a .NET app inside a Habitat package and run it on Arch Linux, which is pretty cool. And you don't have to run mono. We're talking actual .NET. So pretty nifty when we get that landed. So, cool, still on time. So, trying to sum all this up. So Habitat's approach, applications as distributed, fully automated, and capable autonomous actors. Immutable applications, but they are flexible, and you can make configuration changes just by talking to a REST API or by writing in hooks to define behavior as to what they should do in failure scenarios. It bundles what your apps need to run and nothing else. Operating system cruft stays over here, application stuff stays over here. Embedded automation choreographs applications with topology changes. A network with no reliance on external services and no single point of failure. So this is the best of both worlds. And you can provide a continuous deployment without the traditional application release automation tooling, which, as we kind of talked about earlier, was brittle and painful. So the solution is the same for new and legacy applications, and this is where it really gets interesting. It's one thing to just write a quick Node.js app and drop it in Habitat. That's pretty easy. But when you start talking about dropping a .NET app in or a big Java stack, which we've already done, you actually have a way to, like I said, wrap these applications with a lot more intelligence and awareness than they had by themselves. So this is a great one. You may have heard this before. Cloud native is a code word for rewrite everything. So if you look at something like, something like Cloud Foundry or some of the other kind of new PaaS services, they're super great. But what about if you have this nasty enterprise application that you've been running for the last 10 years, and you're like, how do I put this in the PaaS? And they're like, oh, you don't. You rewrite it. Not everyone has the bandwidth to do that. It's a really cool thing for those who can and who can live and die by 12-factor or the 12-factor stuff. But that's not always possible for every environment. And that's kind of why Habitat is really important, is because it embraces both the new stuff. So you're running this you're running Mesos, and you actually have Habitat running in each of your little containers. But also for the big, nasty, ugly enterprise apps that you'd like to move off of Windows 2003 potentially. So this is everything that I just said in one quick bullet point, because I just dropped a lot of information. So Habitat is application automation that enables modern application teams to build, deploy, and manage any application in any environment, from traditional data centers to containerized microservices. So you're probably going to ask, doesn't something already do that? So Docker, we use Docker as part of our tooling, but at the same time, Docker is just the unit of running a thing. Docker itself, you think, ignoring like Docker Swarm and things like that. Mesos, we actually we have Mesosphere integration. We drop Habitat apps into Mesosphere all the time. But at the same time, the apps are generally specialized because the grid is the unit of automation. HashiCorp tooling, they have all of the tools that we need to build these application stacks, but a lot of these are around either the kind of what we consider the traditional ways of doing things. I live and die by Packer and Vagrant for one of my projects, and I can't think of living without them. But at the same time, these are not necessarily things I would want as part of my application stack if I could avoid them. I mentioned the cloud native rewrites. I don't mean to pick on Cloud Foundry at all. It's just one of the biggest paths that's out there. And then your traditional config management. Problem with them is they're operating system centric. And this Habitat gets you away from worrying about any of your operating system concerns. So we believe that all applications, both greenfield, legacy, whatever, they can become the natural, that Habitat can become the natural place where all of these applications live in today's modern application developer world. So because of bandwidth and, I'm just on time, I'm not going to do a demo, but we have, if you go to habitat.sh/try, it's actually very similar to the mini Mesos one. It's in browser, got a terminal, you can do all the cool things. Really, really slick demo. It's got a bunch of great tutorials to getting started. And then, of course, Habitat is open source. So please go there, yell at us, have ideas, and I will open for questions.
Yeah, we have time for 2 questions.
Okay, so with plans, you basically build an applications.
Mm-hmm.
So don't you think that you are throwing away the collective experience of 25 years building packages on Linux?
Yeah, we are.
Yeah? And you are
Well,
okay
we
with
are,
that?
let's just say we are and we aren't. The package management problem, so package managers themselves, I mentioned that I hate all operating systems equally. Distro packages, they're terrible. You end up, if you actually really want control over them, you really want to know what's in them, you're going to build them yourself anyway. And what we found is that a lot of people end up building these things themselves. And being a release engineer, I like building an artifact from source because then I actually know what's in it and I know all the dependencies. This is about getting that tight control and being able to get away from the operating system ones. We have our own libc and everything, so everything, like I said, is distributable runtime, and that for us is a much bigger advantage than trying to build a package for each different OS. Because that's where we've seen, that's actually where the fracturing and the problem has created, or that's a problem that it's made. So it's not that we're throwing away, we're still using in there, you'll be making, and this compiles things, but we're also kind of, it's a bit purist in that if I want to run Redis, I don't want to run this distro flavor of Redis, I want to run Redis from this version, with this source, with this OpenSSL, and then run those. So you are highly specific. I wouldn't say we're entirely throwing things away, but Habitat was very much a complete rethink of how you would want to run applications and keep them separate from the operating system. So we are kind of saying, we don't care about your operating system. That's on purpose. That's a design goal.
Okay, thank you.
Yeah, good question.
One more question? Nope. So let's leave the rest of the discussions to the lobby. And thank you so much, Seth, for presentation.
Thank you.